Hey everyone. Today, what I'm going to present to you today is something about what is called image classification. Um, and what it's in the end, it's about image classification. It's not what you saw so far the last couple of meetings, but it was about typical numerical data. Today we look more into what you can do with image data, and one key concept of it is the image classification. So typically, when you work with images, a lot of the time you want to classify something. Like, for instance, you have a picture of a cat, a dog, a chicken, and when there's a new picture of a cat, dog, chicken, you want to have a model, for instance, telling you, oh, that's a cat, that's a chicken, that's a dog. That's in the end what you do with image classification. You train a model with tons of data showing you, for instance, cats, dogs, chickens. Then you want to predict based on how the tail of the dog looks. Ah, it's a dog. Based on how the feet of the chicken looks. Ah, it has to be a chicken. And so on. That's the concept behind. But that concept is quite powerful when you translate it into industry. So we're having clients, for instance, they're checking their paperwork. Is a stamp on the paper? Isn't there a stamp on the paper? Or in production, are two metals rightly welded together? Or another use case we did is like, is there some oil on the seal or is there no oil on the seal? So there are various of applications where you can use images to detect in the end if there's a certain scenario true or false, or if a certain scenario belongs in a one class or another class. And a lot of the time when we look as well into the industry, it starts with you need as well some equipment for that. A lot of the time there's not a camera available in the production, for instance, or the IoT infrastructure behind is not there to really do image analytics. And therefore we're having as well a product which is called Altair AI Edge, which in the end is a smart device which you can mount directly at the machine, and with that you can monitor anything because instead a camera which is connected through IoT to our platform, and you simply have such a small icon, drag and drop it in, and with that everything is configured, and you just need to plug it, basically plug and play it into your production application you want to use, and then you can use a model based on historical data, train that, and then you're able to detect what you want to detect. Like I said, typical applications is like to see if some quality is good or bad, or you want to see like if a color is right or wrong, or if something is filled or not filled. Or other example, when you look into welding, is it correctly welded or not correctly welded? So basically, this design is really designed to make AI or machine learning based image analysis easy. And an example how this could, for instance, be mounted on a table where typically you would want to weld is how it looks like that, where you have your camera looking into a certain spot where you would put in the weld, and then you can see if it's rightly welded or not rightly welded. And to look a bit closer to this application, now we have here a picture, and this picture is basically made every time you weld some two metals together, you would get this picture. And then what you would have is like, you would have basically those, what you saw as well already in the previous series, those low code, no code blocks, where you would define your logic, how you would now do the image classification. So in a first step, we would read the image. Then we would transform this image into a data table and do some data preprocessing. And then it is fed, in this case, into a neural network where you then would do the prediction based on historical data, if it's correct or not correct. And every time you weld two new parts together, again, you would take another picture, would run it through the system, and the system will tell you, in this case, you would see like, okay, it's good. The class is good. It's rightly welded together. If there would be something wrong with the weld, then it would tell you, no, it would be not good. And see as well, like you get this rectangle. And as well, like in yellow, it tells you, oh, it's good, not good. And basically, this is like how you can easily make with low code, no code, those classification of the images. And once you're basically done with that, you're able as well to just box that in and to group this into one template, and then you would push it to the box and as well can share it with colleagues, can deploy it, and it's super easy to build. And that's one of the most typical ways how you do image classification. Use a supervised machine learning model, which you train on basically previous data, previous images, which you have basically images from something from the one class and something from the other class. You train this model, and then you use this model to predict. Sometimes you don't have a label. You don't have the luxury of have this label. Like for instance, that where like your weld is good or the weld wasn't good. In this case, you have the option as well to use what is called pixel aggregation. So sometimes you can just use mathematics to then like basically do more, I would say more less complex calculations onto your picture, basically onto your data, to do like something like what is similar to what I would call it condition-based monitoring. So you define conditions in those basically tables of the image, and based on this you can then perform the data mining and you can detect certain scenarios. Like for instance, if a color is red or blue, or if a rectangle is filled with something or not filled with something. And to show you how to make it a little more clear how such pixel aggregation would look like, we can look in here a little bit more detail. For instance, we have now this thermal picture of a person in like that right rectangle. And in the first step, what we do now is we transform this to a data table. And as color picture always has like red, green, blue portions, you get 3 tables. One for R, one for G, and one for B. And with these tables, you can now perform any type of data analytics and data mining. And in a first step, we just separated those 3 tables. So we get now one black and white option following the red scheme, one the blue scheme, and one the green scheme. Already having 3 different tables now. And next step, for instance, we only want to have the rectangle and extract everything else. Therefore, for instance, we simply aggregated those 2 together and put the delta and then put in the delta from the third one. This is in the end how you would work with what it's called pixel aggregation. And you can do a lot of different things with that, from Fourier transformations over like calculating different sums or performing some condition monitoring. There are a lot of different options and possibilities what you in the end can do with image mining in case you don't have a label. But like I said, if you have a label available, always go with a label, go with a CAN, with a neural network, and then you're able to pretty good to train a model to then predict you if it's belonging to one class or the another class. But that's not just the only option going with like pixel aggregation. Here again, simply the workflow would be now in this case directly again from the edge device, what you saw earlier. We would collect the image directly from the edge, from the machine where it's sitting. You then perform some cutting, like the operator for cropping it. You transform it into a table, then you perform some aggregation, some calculation, and based on this, it will tell you it belongs to on or off. It belongs to the one condition or the other condition. That's an option you can do in case you don't have a label, and follows pure business logic and mathematics. But if you have a label, like I said, then you typically go with like similar workflow. You get your image, then you do as well some pre-processing of the image, and then you feed it into a neural network, and then you get your result if it depends on how the image looks and in which class it belongs. And a third option is sometimes when you don't have a label is to just leverage large language models, the famous Gen AI. So thanks to large language models, you have nowadays as well the option to feed in images. And for instance, here we have this handle, and we just ask then basically ChatGPT, OpenAI, Bard, or another large language model to please describe to me how the handlebar is, or if it's in a vertical or horizontal position. And a large language model is quite good then as well checking the image and telling you, this handle image is in a horizontal position or vertical position. That's another way how you can handle image data in case you don't have a label available. Because in an ideal case, you would have for a lot of pictures of the handle in the vertical position, a lot of pictures and handle in the horizontal position, and then you would basically train a model based on these information labels, and for new data, it would tell you, okay, the handle is like that, it's horizontal, it's like that, it's vertical. And for a large language model, you don't need this kind of information. Another example where LLMs work perfectly is as well, like for something like you have like a display where something is written, and you want to ask, basically, you want to know, okay, what's the number written on this display? Or as well, like if it's a bigger text, please summarize what is written there. You can simply use then, again, a large language model feeding in the picture and then telling you, this is a summary, what is written on this picture. Or like showing here in this example, which is in this case, reading a human machine interface from a production machine. The display tells us currently the machine has 120 degree. Again, another option you can do, and all you need to configure for such an LLM setup is you need to put in the token to your OpenAI, the API token. You need to establish a connection to your AI edge or to the image going in. And all you need to do is write in the prompt and specify how many tokens you want to maximize. That's it. Now imagine if you would need to code this and build this by yourself, it would take way longer. And it's a super nice, intuitive, and easy way to build an image model. And the nice thing is all of those things can be natively through our platform as well directly deployed on the edge again at the machine. So it's not just a data analytics layer and a data analytics platform where you can perform your data analytics. At the same time, you can use it as the IoT infrastructure, for instance, where you do all the management of the models at the edge. So for instance, if you have multiple of those machines and you need to update all at the same time, for instance, you can have their central management of all the AI edge devices and manage them in an efficient way with all the other IoT data coming in. And that's basically the short showcase today about image classification. To simply summarize the different ways how you can work in our platform with images and how you can with that then perform image classification. The first way and the best way is always if you have labels. If labels are available, you would always go with the classic way of a CNN, a neural network, and use those to perform your prediction of your images and the classification of it. If you don't have labels available, you have an option to go with pixel aggregation, where you first of all transform the image into in a table and into the different color schemes, RGB. And then based on this, you then perform some kind of mathematics, business rules, analytics, Fourier transformations, aggregations, to then get to the right result, which would deliver you, based on this scenario, it belongs to one class or the other class. The other option, instead of just using a CNN, you can use as well large language models for the interfacing, which could then describe you what they would see on the picture, and with that would support you getting to those results. All those use cases we did already with clients, and if you're interested, please reach out to us. We can run you through detailed demos, which take a little bit more than 50 minutes. But today was just like to show you some glimpses, what is possible. And then we can go into more detail in a follow-up session and go through the end-to-end processes if you're interested. And with that, thanks a lot for your time today and see you next week.